operations or functions? Same thing. That's fine.
I don't even know what a piece was. I don't even know how to piece was. Okay. As long as you talk to me.
All right, operations with functions. The hardest part about this is going to be the combined domain, and we're going to talk about what that means as we go. Addition.
Miss me, that actually happened when I was kind of like water magically appeared like actually. And I mean so
Charlie.
can we take this outside? No. It's not like
We're going to talk about 5 operations. One more. Addition, subtraction, multiplication, division, and composition. We did composition last year. I'm going to show you. All right. Or function operations or operations with functions. Yeah. Don't worry. It is.
Bring back Terrence. Bring back Terrence.
Charlie.
Bring back Terrence.
Sullivan.
Justin Christon.
And you plug it in for every X in there. Yeah. Yeah. All right, listen. All right. Nothing is different. These are all things we've already done before. F of G of X, that's composition. Yeah. Yeah. All right. So the fog is F of G of X. It's composition. It's taking G and plugging it into F. Okay. Now. Precisely. Are y'all done? No, we're not butterflying.
Yes.
All right. F and G.
Miss McGee.
No.
What about
Alright, so F and G are defined initially, and then we will do all of these operations on F and G. Okay, F and G, here's the new part though of this. F and G. I will show you what I'm talking about. It's not new, I promise. The new part is the combined domain. And all this means, now tell me some things algebraically that impact the domain. There are 2 main things that restrict our domain.
line? Star.
Open or close dot.
Graph.
Okay, I'm just.
We are giving out answers.
That's a circle. F of G. What impacts domains? Number one, a fraction, because denominator can't be 0 because that makes it be undefined. In other words, if I had the function 1 over x plus 2, x could never be what? Oh my gosh, look at that. Negative 2. Thank you. What is another situation that would impact my domain? Please, oh please.
Multiplication.
Okay, I'm just going to tell you.
Division.
Oh,
That is division. Subtraction.
a radical.
You can't have an I.
Yeah, that's exactly right. No negative under a square root. So if I said f of x equals the square root of x, and I said what's the domain there, I have to say that x has to stay positive, right? How do I say that? Yes. The domain, including or excluding? That tells me that x has to stay positive. If I wrote this in terms of the domain, it would be negative infinity to negative 2. Got to leave that value out. All right. Why? Because we're all lost? Or because it's wet? Okay. Charlie. If your feet get covered because the water gets so deep, I will stop the lesson.
Oh, Miss Kitty, I'm actually amazed whenever
You see the water? Yes, I've seen it. Yes, I've seen it. Yes. Okay.
I can't swim. Yep.
Just give up. All right. So, combine domains.
Oh my God.
Charlie. The domain, the combined domain, you take the domains of each function when you combine two functions. In other words, if I told you f of x was the square root of x, why is it doing that? Let's say, okay, so you know about domain, but all I want to say is when you combine functions, in other words, this function leaves out negative 2. This function leaves out anything negative, right? She's coming.
Yeah, why you can't even bother?
Let's say I want to multiply them together. I have to look at each individual function domain, and then I also have to look at it all together. So if it's left out of one, it has to be left out of the combined one. No, you have to. You have to do that. So this would be square root of x over x plus 2. It's just going to be, the domain for this one would just be 0 to infinity. Now, had I left out, let's say, positive 2, like let's change this. Let's make this Let's say g of x is 1 over x minus 2. Now what's the domain of the new g of x? X can't be positive 2, right? So now the combined domain all right, so I've got to leave out, now I'm not looking at this g of x, I'm looking instead at these two. But the point is, for this one, right, it's greater than 0. For this one, x can't be 2. So how do I write that all together as a combined domain? That's right. Because I take everything, but I just leave out 2. Okay, that's the only new part of this stuff. Okay. Okay. Let me show you another example. Tell me when y'all got this. Good. Yes.
Oh.
Test Thursday. Bro, you know what? If I got through the lesson, you got time to do your homework in class, and then you wouldn't have one. Y'all back there worrying about water on the floor. The Slade is squirting on the floor.
Whoa.
He's squirting his water on the floor. Y'all. Some days you warned me about what, Wyatt? Find the new function and state its domain. Don't make it harder than it is. It's literally just add them together. This is addition, right? Uh-huh. Can you combine any of those things? No. So that's all I do to write it. Now the new part, what's the combined domain? Well, what's the domain of this one as it sits? It's a parabola. Y'all can do this. There you go. What's the domain of G? So now when I combine these, I have to look at this. Are there any additional restrictions here? No. Because I can't put a negative under the radical. And that's one of your parent functions. For the square root, yes. Yes. So now the combined domain would be 0 to infinity. Because this one, it has to be the intersection of the two domains. It has to be what they share from the two domains. So this one has everything, but this one is only positive numbers. So of those two domains, what do they share? They share the positive numbers, so that's what you give it. Let's make it a little bit harder. Same F, same G, yeah. Find the function and give its combined domain. Yeah? I mean, know what they do. How is the domain of this one different than the domain of the one above it? No. I mean, if you can, you do, but you can't simplify this one. Say again. You're dividing, so what's the difference here? Domain-wise. I already know that x is bigger than 0. It can't be 0. You're exactly right. You're actually right. That's exactly right. So if it can't be 0, how do I say that in my domain? Not including 0, so I do a parenthesis. I just can't have the bottom be 0. All the other domains hold true. Mm-hmm. Right.
How do we know the bottom can be 0?
Because the bottom can never be 0. How do we know what? How do we know it's not negative infinity? Yeah, it would make it imaginary on the bottom. And we look at these domains in the beginning, so it has to be a shared domain anyway. It has to be what they share. Right. A denominator in a fraction cannot be 0. The heck is going on? All right. Yep, same thing. So I'm going to do the square root of x minus 2 times the square root of x plus 6. If I needed to combine that, I could combine them under the same radical. And I'd have the square root of x squared plus 6 minus 2 would be plus 4 minus 12. Be okay if you left it there too. But let's look at this for just a minute, because what has to happen here, let's look at the domain individually. What's the domain of the first one? It's got to be bigger than, actually. Yeah, because that would be 0 under there. It can be 0 as long as it's not in the bottom of a fraction. X minus 2 has got to be greater than or equal to 0. So if I add 2, x is greater than or equal to 2. Bracket includes, parenthesis excludes. So combined, right? All right, so think about it on the number line. This one goes from -6, bigger. This one goes from 2 and bigger. So I have to give what they share. That's my combined domain. So what's the combined domain? 2 to infinity. It doesn't matter that this one can go lower because this one can't. Or can you just look at what? You know that combined, yes. Yes, well, it's two parts. It's name the new function and give the domain. Okay, because there's two parts to this. There is part one, which is name the new function here. Part two is what's the domain of the new function, and that's here. Yes. Thank you. Yes, yes. All right, let me make it a little bit hard. Let's do some composition, and I'll be done. Oh, my goodness. Okay, so you need to look for radicals and square roots. I mean, radicals and fractions, right? If it's a radical, take what's under the radical, set it bigger than 0. If it's a fraction, take the bottom and set it equal to 0. Yep. No. We did it in algebra 2. It's okay. Fractions, all right, look, if you're confused about what we do and how we restrict our domains this way, if it's fractions, the bottom can't be 0. I guess I did put this in the notes earlier, but that's okay. Square root, take what's under the square root. What's that called? The radicand. Greater than or equal to 0. This tells me what I leave out. This tells me what I include. Radicand. I don't know. Yes. The bottom of the fraction. The radical's greater than or equal to 0. That's for your domain. So if I look at the domain, look at f of x. I don't see any radicals. I don't see any fractions. So I'm going to say the domain here is -infinity to infinity, and that makes sense because that is a linear function, yes? Over here, that's a fraction, so I need to look at if it's a fraction, I need to not let the bottom be 0. So I need to make sure x is never what? Look at the bottom though. All of this can't be 0, so I need to make sure, right, -1. -1 would make the bottom 0. So my domain would be -infinity to -1, -1 to infinity. Before you can find a combined domain, you have to find individual domains. Yes. Right. Why am I putting it? I'm excluding it, right. I'm keeping it from being. I'm saying x can be anything except that. Say that again. It can be anything in the world except -1. Just for G. x plus 1 can't be 0. So that would mean that x can't be -1. Right. That's what this is saying. Right, because it doesn't include it. This statement says x can be anything in the world except -1. Now, that's okay. Now find the composed function. In other words, f of g of x and its combined domain. No takers? Yes. All right, so this is saying take g, and everywhere there's an x and f, replace it with g. Well, what is g? G is x over x plus 1, right? So I'm going to take this f, and everywhere there's an x, so I'm going to say 3 minus x over x plus 1. Yes, then you would find a common denominator, right? Remember that we did with the rational functions? X plus 1, x plus 1. So this would be 3 times x plus 1 minus x over x plus 1. That's the answer. That's the combined function. What is the domain? What's the combined domain? Wyatt? She's the second block. If this domain is negative infinity to infinity, this domain leaves out -1, and the only thing happening in my new function is I need to leave out -1. Then what do they all share? It's just leaving out -1. Y'all are making this way harder than it. What are y'all laughing at now? I don't know. What if I put a number in here? What if I said, what is f of g of 1? You just put 1 in for x. So you could do it either way. You could do it, now that I've got this combined this way, I could just say 2 times 1 plus 3 over 1 plus 1. Okay? But if I hadn't already gone through all that, yeah. What do you mean? So, but the x got replaced with x over x plus 1. Does that make sense? So if I didn't plug in the end, what I could do was do f of g of 1. I could find, I know y'all remember doing this in Algebra 2. I remember doing it extensively. G of 1 would be 1 over 1 plus 1, which is 1/2. Now I could plug in f of 1/2 and plug it in to come back to the same thing. Either way would work. Oh my goodness, I don't know how to take y'all stairs in silence now. What? No. Why did you ask? Yes or no? No. No. Charlie. Yes. Myra said go. Try this one on your own. Is this the same thing? All right. Well, then tell me this. What is G of 9? You won't do domain whenever you find a specific value. Only whenever there's an X in there. Sorry. Okay, so that's what G of 9 is. So now I can say, okay, well, if G of 9 is the square root of 5, then really what I'm looking for is F of square root of 5. So I go back to F and I say, okay, square root of 5 squared plus 5, it's not X, it's square root of 5, which is 5 plus, that's it. The domain. Look at the number 1, x squared plus 2x and 5 minus x. What's the domain of those? What are y'all laughing at now? Y'all are creepy. Okay. All right, number 1. What's the domain? Ooh, no. How about G? Why? No fractions and no radicals. Okay, look at number 2. This is the sheet that I just gave you. No, then you have to combine it together and look. But if you can figure out the individual, it makes finding the combined a lot easier. That's right. Why? Can't be 0 on the bottom. How about number 3? You got f of x is the square root of x minus 7. And then you've got g of x is the square root of 2x. The sheet I just gave you, there's 4 problems for each number. This is number 3. No. Say again. Because 2x has got to be greater than or equal to 0. If I divide both sides by 2, because that's what's under the radical. That's the part that's going to give me problems. This one? Up. Here. Because the bottom cannot equal 0. Say that again. The domain for g of x is just 0 to infinity. I was just showing you how I got it. Flip it over to the back. Number 4. F of x is a quadratic. What's the domain? What about g of x? How do you know there are no restrictions on those two? There's no radical and there's no fraction. How about h of x? Why are you leaving out 0? Fraction, the bottom can't be 0. Okay.